In this video, I'm going to work through problems 1 through 7 and number 10 to help you prepare for the first part of tomorrow's test. So when I'm looking here at simplifying a negative square root of negative 40, I'm thinking that as negative 1 times the square root of negative 40. Now that negative sign comes out and becomes a negative 1i. I know the square root of negative, sorry, not negative 1i, just square root of negative 1. I know the square root of negative 1 becomes an I. So I have negative from being in front. The square root of negative 1 is I. And now I can break down 40. I'm looking for the largest perfect square that divides into 40, which is 4, and 4 times 10. Okay, we know the square root of 4 is equivalent to 2. So negative 1 times 2 is negative 2i square root of 10, and let's find that. That's going to be option C. Now, when we look here at this complex plane, we normally think of this as an x and y. Remember that in a complex plane, our real numbers align with what we think of as the x-axis, and our imaginary numbers align with the y-axis. So when I look at this point, I'm going to the right 2, so positive 2 needs to be in front, and then I'm dropping down 3. Option B. Okay, let's look at number 3, which is I raised to the negative 33. Now this would be the really long way of doing it. I'm going to break up that, 35. I'm going to break up that 35 into groups of 2. So there's 2, 4, and I'm going to keep going, right? And each of those I squareds, remember, is equivalent to negative 1. So what I'm going to do is I'm going to count here, and I'm going to start doing by negative 1. So here's 2, 4, 6, 8, 10. So when I do one group of 10, I have 5 of them, and then I'll have another 5. So you can visualize this. And then I'll have another 5. Every negative 1 is equivalent to I squared. So I'm up to 30. And then here we go. We're at 32, 34, and a remainder 35. Let's count the number of negatives. 5, 10, 15, 16, 17. I have an odd number of negatives, which results in a negative sign. 1 times 1 times 1, all the way to 70 times is 1, and we have a remainder I. Correct answer is negative 1i, option D. Let's look now. Now this is not multiplying, this is subtracting. So I'm going to distribute the negative sign to everything behind. 3 plus 5i, and then I'm going to go minus 8 plus 2i when I distribute. 3 minus 8 is negative 5, 5 and 2 is 7. And we're going to find that option in option C. Moving on to number 5. This is multiplying. So I'm going to FOIL, multiplying the fronts, multiplying the outsides, multiplying the insides, and last, 2 times negative 3 is negative 6 with an I squared. Remember, I squared can change into negative 1, and we have negative 6 times negative 1 is 6. 6 and 6 is 12. Negative 9 and positive 4 is negative 5i, and we will find that option on option A. Let's look at number 6. Now, in order for me to simplify number 6, I cannot be left with an I in the denominator. So what I'm going to do, because this is the same as 20 plus 0i when it's a plus bi form, what I'm going to do to keep this same fraction, but eliminate an I in the bottom, so I'm going to multiply by the conjugate of the denominator. Okay, here we go. So, multiplying the top. So I'm going to do FOILing front, outside, inside, and last. Now, these zeros are just canceled out, right? Because really, I could have just taken 20 and got 60, as you can see, and negative 20i. So this is going to be, I'm going to write that a little bit better, 60 minus 20i. That's going to be the numerator. When you multiply conjugates, you're only going to have to do the front and the back. Positive 1 times negative 1 is negative, and I times I is I squared. We know that I squared is equivalent to negative 1, and we end up with 10. This 10 needs to be shared with both sides, so we have 60 over 10 minus 20 over 10. 60 over 10 is 6, 20 over 10 is 2, and we're finding that option in option C. Let's look now at number 7. At number 7, we're asked to solve, so I'm looking at what are the factors of 4. 1, 2, and 4. And we're lucky because the leading coefficient is 1. So I'm going to come off to the side here, and I'm going to test 1. 1, negative 1, 4, negative 4. And I'm going to use a pencil in case it doesn't work, so I can test a different value if needed. Let's start by testing 1. I'm dropping down, multiply and add, multiply and add, multiply, and we can see that 1 works. So 1 is a solution that does not have a 1. This has a 1, this has a 1, this does not have a 1. Okay, when there's only 3 remaining, I have no x's, 1x, and 2 x's. We would check, we'd check if I'm able to factor this, which I'm not, then I could use the quadratic formula, or there's a shortcut. Whenever the b term is 0, this cancels off. And then I solve. Two answers. The negative sign comes out as I, and the square root of 4 is 2. So I have positive and negative 2i. Here's positive and negative 2i, option B. Okay, let's flip over now, and we're next going to do number 10. Which polynomial has the following zeros? So I'm going to write this right now as a product of linear factors. So it's going to be x minus 2, x minus 3i, and x minus negative 3i. Now, I know 2 negatives make a positive. I'm going to always start by multiplying the conjugates. All right, here we go. When you multiply conjugates, you only have to do the front and the back. So x times x is x squared. We don't have to do the outside or the inside because they're additive inverses and cancel out. And then I have negative 3i times positive 3i. Negative 3 times positive 3 is a negative 9. And I have an I squared, which is equivalent to negative 1. This becomes x squared plus 9. So this portion is x squared plus 9, and I still need to multiply by x minus 2. I'm going to FOIL that right now. Front, outside, inside, and last. And when we write it in standard form, x cubed minus 2x squared plus 9x minus 18. And this would be the correct answer, option B.